Good morning. Statistics says that when you analyze the numbers, you should be able to tell a trend, or you're supposed to know how things are flowing so that you can see the futuristic, and you can decide using numbers to make a decision. Therefore, according to an FBI report in 2017, it says that 18.2% of crimes do happen on property, on properties. Unforced entries account for 36.2 of these crimes, and 57.5 do account for the forced entries. Our project, which is Team MID, stands for Made in Dallas. We are focusing on the 36.2% of unforced entry, and for that, we are looking for perfection. We are in pursuit of perfection. 36.2% is high of a number, so we want to reduce it. My name is Liki Ondigo, and I'm a computer engineering major. He's David. He's Hong Ton, a computer engineering. He's a computer engineering major too. Ming Hong is a computer engineering major too. We have Elmeda Osamoa, electrical engineering major, and we have David Nguyen, electrical engineer. I'm gonna pass it to Hong.
So our project is a door lock that's around the deadbolt. A quick overview of the functionality of the lock is that initially when the lock is in the unlocked state, the Bluetooth will be on, which is our proximity locking. So similar to most modern cars, when the user walks away, the door will automatically lock. Now that the door is in the lock state, the Bluetooth will turn off, which will stop advertising its connection, and the accelerometer will turn on, which is our forced entry detection system. So if the user wants to unlock the door, he or she can either use fingerprint, keypad, or in case of emergency, physical key to unlock the door.
Proximity locking is one of our promised feature. To implement that, we use BLE technology to monitor signal strength data. And since the signal strength data is not consistent, so we take a sample size of around 30 signal strength data to take average, and then use that to determine if users are far away enough. Since it already exists a threshold, and as soon as a threshold is exceeded, our lock will go to lock state and drop our connection, Bluetooth connection, and after a lot of testing, we were able to find a certain threshold that we wanted that would be exceeded if user is more than around 15 plus or minus 3 meters away. And I'm gonna pass it to Amanda to
Forced entry detection is another feature that we use on our device. In order to implement this, we use an accelerometer, and that tracks the speed of the door as it's opened. For further testing, we use orientation detection, and also we set a threshold of 45 degrees in order to determine if the door is open.
We also detected that if there's a presence of another person by using different knocks. So we used, for testing, we used the thicker door at the SPM, the thicker wood doors that you find at most residential homes. And we used varying amounts of knocks, from light tapping to a harder bang, to set the threshold of where the knocking range is. All of our devices are made from scratch, so the housing, we've 3D printed ourselves. For smaller form factors, we printed our own PCBs to fit all of our individual modules within that housing.
So, any question?
So, yeah, I have a question. So, there's a device on the market now. It's a few devices. One is by UltraLock, where yeah, I get it too. So, I mean, it locks out. It stays locked all of the time unless you change the mode. So, as soon as you open up, it gives you probably 3 seconds to open the door, and as soon as you shut it, it locks back. So that's something that I mean that 15 seconds, somebody could be waiting in some bushes or something and just run in your house in that 15 seconds. So something I want to mention.
The thing is that it's not based on 15 seconds. It's based on the user distance. So we have set up that it's 15 plus or minus 3 feet.
3 feet.
3 feet. 3 feet. 3 feet. So this is around the user up to probably around the user driveway.
I guess it depends on how fast the person's walk. That could be 30 seconds. That could be a minute to get out that far if they're walking slow.
So it's Bluetooth connection to wall.
to the microcontroller.
On the other side.
So,
So the user's got what? Carrying what? What's it
A
communicating?
smartphone?
A
Smartphone, yes.
So the Bluetooth system is that it will connect to the user mobile app. That's where
So what happens if they don't have a cell phone?
They have like you can lock it. Yeah, you can lock it with a keypad. That's one way of locking it, and Bluetooth locking it is for in the scenario that you forgot to lock the door.
Now, I think I'm going back to his things. If he doesn't have a cell phone, it automatically locks, kind of deal.
Yeah,
Timer.
This is not, it's unattractive. I mean, I would not have that on my front door. I mean, is this more for commercial use? Because, I mean, think of it, I mean, can you make that smaller? Can you make it more like streamlined so that it's like elegant looking? Because, I mean, I would not have that on my door, in my house.
So this is just our project of initial idea that we want to test out. So we have not really think much about going to the market or commercial. We just based on different design criteria, so we can try to implement into a project that we tried out different concept and test our skills.
Within the 3 feet, can I lock it myself using the cell phone instead of waiting for it to lock?
Yes.
I can, using
Yeah.
Bluetooth.